Hello students, welcome back to the third video of this playlist. So in this video we will be solving question number 3 from June 2023 P4 paper. So let's get started with question number 3. So in question number 3, if I give a short review on question number 3, this is basically it is a question from integration. To be more specific, it relates to concepts of integration by partial fraction. Okay, this process. Okay, so this process, the concepts behind this question is basically discussed in chapter number 6 of your P4 book. So that means if you have to be able to solve this question, that is question number 3, you should have clear idea and you should have practiced questions from chapter number 6 of your P4 textbook. Okay, so let's get started. In question number 3, you can see a function, a fractional function f of x is given there, which is 8x minus 5 over 2 twice of x minus 1 times 4x minus 3, where the range of values for x is given, x greater than 1. So the first question asking there, express f of x in partial fractions. We need to express f of x in partial fractions. Okay, so what we do in partial fractions is that we consider 8x minus what was there, 5 over 2x minus 1 times 4x minus 3 equals to what? We consider this as a over 2x minus 1 plus b over 4x minus 3. Now, most importantly, most of the students get confused here, like how can we consider the partial fraction? Because we know partial fractions can be in different forms, like ax plus b, or like a over something like that one you can see here. So it can be in different forms. So in what cases we consider which partial fraction? So to understand this, you need to understand the type of fraction. Okay, like here you can see that the power, like we know that the type of fraction, it depends on the power of the numerator and the denominator. Like the types of algebraic functions, to be more specific, it depends on the power of the variable. At the top there is the numerator and at the bottom there is the denominator. Okay, so if the power of the denominator is greater than the power of the numerator, that is the case here, in that case these type of algebraic fractions are called proper fractions. When the power of the denominator it is greater than the power of the numerator, we call these as proper fractions. So for proper fractions, always keep in mind that the power of the denominator it is greater than the power of the numerator. That means for this type of fractions, the partial fraction would be in this form as shown. Okay, now next is what? Improper fractions. What we call as improper fractions? Improper fractions basically has the power of the numerator greater than the power of the denominator. Okay, so if I give an example, like if it was 8x cube minus 5, just for an example I'm giving, 2x minus 1 times 4x minus 3. So in that case you can see that the power of the numerator, the maximum power, we are considering the maximum power, it's 3 there. So you can see that it's what? The power at the denominator, that is 2. That means the power at the numerator, that is what? Greater. So in that case this is called as improper fraction. And for improper fraction, we know that if we consider numbers, if we consider numerical fractions, 5 over 3, this is an improper fraction. If I write 5 over 9, that is a proper fraction. This is what? Improper, and that is proper, right? So we know that improper fractions can always be transformed to mixed fraction, right? Mixed fractions are those what are in this form. So 3 times 1 plus 2, 1 is to 2 over 3, right? This is a mixed fraction. Like is that improper fractions can be also represented as mixed type of what? Algebraic fraction. That is, you will get ax plus b plus c over 2x minus 1. It might not be correct, but I'm just giving it as an example to let you understand like how it works, like d over 4 x minus 3. Try to relate with numerical fractions, like how do we consider it numerically, and how do we consider, like how can we consider it algebraically. So if you make a relationship, it will be better for you to keep in mind, right? Because most of the students feel difficulties like keeping this process in mind, right? Okay, so this is the second case. This is the second case for what? Improper fractions. Okay, improper fractions we consider like this. Now remaining is what? The third process. That's the remaining only. That is when the power, like we consider improper. For improper, the power of the variable at the numerator will be greater than the power at the denominator. For proper, the power at the denominator will be greater than the power at the numerator. Now remaining is what? If both the powers are the same. If the both power are the same. Let's give an example using numbers, numerical fractions. 5 over 5. It's what? It's 1. You are getting an integer. You are getting an integer, right? So in that case, let's give an example for another what? Fraction for the third process. 8x squared over twice of x minus 1 times what? 4x minus 3. Fine, this is the third step, and this was the second one, right? This was the third, second, and this is the first. This is a proper fraction. Okay, so this is, first one is proper, second one is improper, third one is what? It is it's, you can't tell it by a name. You can say when the power is when the power of the both numerator and the denominator are equal. In that case, we will definitely need a constant. So a plus what? b over twice of x minus 1 plus c over 4x minus 3. That's it. That's how we can consider the 3 cases for partial fractions. Okay, so let's see what we do. We multiply both sides by the denominator, so we'll get a times 4x minus 3 plus b times twice of x minus 1. Now we will put what? We put the value for x such that one of the terms, either a or b, will get what? Cancelled. Okay, so what we can consider here? We can consider x equals to half, so that b gets eliminated. So that would be 4 minus 5, that is negative 1, equals to half of 4, that is 2 minus 3, that is negative a. So we got the value for a, there is what? 1. Done. Now we need to put x equals to 3 over 4, so that a gets cancelled. So 3 over 4 times 2, that is 3 over 2 minus 1, that is half of b. Half of b equals to 3 over 4 times 8, that is 2 times 3, that is 6. 6 minus 5, that is 1. So we'll get b equals to 2. So we got the value for a and b, right? So f of x, as in partial fraction can be written as 1 over twice of x minus 1, 1 over twice of x minus 1 plus 2 over what, 4x minus 3. Okay, this part is a bit longer, like it got longer since I have discussed something about partial fractions. I hope it will help you. Okay, so next proceed to the part B. Here hence find the integral of f of x dx. So in that case we need to integrate f of x. So we know that f of x can be simplified and written as a partial fraction. So basically we will be integrating this partial fraction. So what we can write, 1 over twice of x minus 1 plus 2 over 4x minus 3 what, dx. So what we can do, we know that integration of 1 over twice 1 over something, integration of 1 over something is what, ln that. So ln twice of x minus 1 modulus, since logarithm can't have negative domain, so we need a modulus. Now what we need to do, reverse chain rule. Reverse chain rule, that is reverse of the chain rule. In chain rule what we do, we differentiate the part within the bracket and then multiply it with the coefficient. So in the reverse chain rule what we do, we will differentiate the part within the bracket, but then we will use it to divide the coefficient. So in that case the coefficient is 1. So if you differentiate the part within the modulus, you are getting 2. So 1 over what, 2. We divide the coefficient by the derivative of the part within the bracket. So in that case second fraction, that is also ln 4x minus 3 modulus, and if you differentiate the part within the modulus you will get 4. So 2 over 4, that is plus half plus c. That's it, we got the integral. Straightforward. That was for 3 marks. Yeah, done. Next, part C. Use the answer to part B to find the value of k for which integration from k to 3k f of x dx equals to half of ln 20. Okay, so we need to integrate. Let me extend the page. For part B, what we need to do is that we need to integrate f of x from k to thrice of k. Okay, so let's integrate for part C from k to thrice of k. F of x dx can be written as how? We got the derivative already. Sorry, the integral. Half of ln twice of x minus 1. Oh, sorry, it is modulus. Plus half of ln 4x minus 3 modulus. Now definite integral thrice of k and k. Okay, now what we can do is that we can simplify it more. You can take half common from there, then take ln, the base is the same, e, right? Ln means log of natural, that is log with base e. So we can use the logarithmic rule, 2x minus 1, that should be what? Multiplied, isn't it? 2x minus 1 times 4x minus 3, right? So we'll get 3k and k there. Fair enough. So if you multiply, what you will get there? If you multiply it, you will get half ln 8x squared, it's modulus 8x squared, negative 6x, negative 4x, that is negative 10x, right? Negative 10x plus 3 modulus, then the limits 3k to k. Okay, so we got that. So half can be written as what? Square root of 8x squared negative 10x plus 3. Now we need to just put the limits. That's it. If you put the limits, what you will get? You are getting ln square root of, that was 3k squared, right? So that means 9k squared. 9 times 8, that is 72k squared negative 30k plus 3 minus ln square root of 8k squared negative 10k plus 3. Fine. So same the previous rule, right? These are in now what? Division. Sorry, these are in subtraction. So we will use the laws of logarithm. So we can write square root whole square root what? 72k squared negative 30k plus 3 over what? 8k squared negative 10k plus 3. That's it. Now we know the value for this integral, isn't it? That is half of ln 20. So since it's half of ln 20, so what we can write? Ln square root of 72k squared negative 30k plus 3 over 8k squared negative 10k plus 3. This is equals to ln square root 20. Now ln cancels from both sides, and then square both sides. You will get 72k squared negative 30k plus 3 over 8k squared negative 10k plus what? 3 equals to 20. Now what we can do? Cross multiply. You will get 72k squared negative 30k plus 3 equals to 160k squared negative 200k plus 60. Now 160 minus 72, that is what? That would give you 88k squared negative 200 plus 3 30, just 30, that is negative 170k, and then 60 minus 3, that is plus 57 equals to what? 0. Now we need the value for what? K. So what would be the value for K? Use quadratic formula. You get minus b plus minus square root of b squared minus 4ac. So b squared is 170 square minus 4 times 200 times 57. Sorry, 4 times 200 times 4ac. b squared minus 4ac. 170 squared minus 4 times a is 88 times what? C is 57. Okay, square root of 8836 over twice of a, that is 178, right? Yes. So what you will get? Square root of 8836, that is 94. So 170 plus 94 over 178. Sorry, 170 plus 94. Okay, over 178, you will get 132 over 89. 132 over 89, or k equals to 170 minus, that is what? Square root of 8836 over 178, you will get 38 over 89. Okay, it seems to be a bit odd to see the values. Okay, let's see the values for k. Did they give any range or any limit for k? No. Okay, so I think we did some mistake in the calculation. Twice of a, is it 88 times 2, that is 176. That is fine. Minus b plus minus square root of b squared. B squared is 170 squared minus 4 times 88 times 57, 8836. Square root of answer, that is 94, plus 170 over 178, that is 132 over 89. Okay, 4 times 88 times 57, 94. Okay, got it. So 94 plus 170, it will give you 264. Okay, so 264 over twice of a, that is twice of 88, it gives you 3 over 2. Yeah, that was the mistake. It should be 3 over 2. 3 over 2, or the other possible value is 170 minus square root of 8836 over 178, 38 over. Now which one to consider the value for k? Which one we should consider? 8836, it's 94. Okay, we should consider k equals to 3 over 2. Right? We should consider the value for k, that is 3 over 2. Why? Because you can see that which one seems to be like, you can see from the answer. You can see from the answer, like from the values, the two values, k equals to 3 over 2, k equals to 38 over 89. Which one seems to be more acceptable? Definitely k. That is because this is seems to be more even number, right? So in that case, that's why we will consider k equals to 3 over 2. So that's why, okay, the value for k would be what? 3 over 2. That should be 176, because 8, that is 16, 160 plus 16, that is 176. So you'll get 170 minus, okay, yeah, so the value is either k equals to 3 over 2 or what? 19 over what? 44, which is not acceptable. Okay, so ignore this one. K equals to 3 over 2 is the answer for part what? C. And that's all about question number 3 from June 2023 P4 paper.